Hello and welcome today to our webinar for our tmENV product regarding environmental scanning for advanced track monitoring. Yes, what we want to start is today to also tell you something about our upcoming webinar regarding our tmMCO solution, MDC solution regarding modern maintenance and fleet management, especially for track maintenance machines. And of course, what you can also see here is that we have today the webinar about environmental scanning for advanced track monitoring. For who is this webinar for? As normally we have it for machine manufacturers because they get to know the products for their machine, what is possible, and also the capabilities, of course, for infrastructure managers and maintenance companies, that they also get to know the full scope for the product, what we are presenting today, and also the capabilities for their needs. Let's start things off a little bit with the functionalities of the tmENV. The functionalities what we will present today is the cat wire measurement, the ballast profile measurement, the clearance profile measurement, the track distance measurement, and last but not least, the platform edge detection. All of these features have dedicated functionalities, especially designed for the track maintenance process. Starting now also about our idea, how we are developing our products. It's all based on data-driven track maintenance. So all our ideas, what we are having to get our products developed, are designed along the process of pre-measurement to get the data, what we are needing, then for the work preparation, which is then the data analytics and work preparation in the back office or also on the machine. And the next thing is then the work execution based on the data, and while working, again, also the measurement of the data while working. And at last, we have then the transparent documentation from all things from the start to the end. So how we found the track before we started to work, what we have prepared, what we have done, and then also how we left the track behind at the end. And all the products that we present today are designed along the process. On what carrier vehicles we can use our product? So we have what we can see here are a typical tamping machine where the scanner is mounted in front or also on the back, or on the right side you can see a measurement vehicle with also a scanner mounted to measure there. What we have additionally to that two standard use cases is, as an example, a ballast regulator here on the left side, or a very flexible measurement car, as an example here from Robel, which is universal, usable on different tracks and networks, and can also be transported via a truck, as an example. Additionally to that carrier vehicles, what we have shown now, we can of course also mount them, as an example, on a catenary crafter, what we have a use case as an example for the catenary wire measurement, or also of course hand measurement devices can be utilized to use our system. What hardware do we need, or what we use? Our lidars, what we're using is our high performance lidar from Regal, where we have really a 360-degree of view, where we have a very high scan rate and also very high accuracy and precision, which is needed for some of the algorithms and also enables, of course, high measurement speeds. If you have lower measurement speeds, and as example for the ballast profile measurement, where the accuracy requirements are not so high, we also offer a low-cost sensor with the SIG lidar, which is completely efficient for that use case and also is, regarding the costs, very beneficial here in that case. What do we need additionally? Additionally to the lidar, we need of course also a device which is syncing all the measurement equipment regarding time, so that we are sure that all the measurements are fit together. We need, of course, also a distance measurement, so a distance measurement wheel that we know where we are with our measurement points. And for some of the features, what we are presenting today, as an example, the track distance measurement and the ballast profile measurement, we need additionally also a super elevation measurement. All these hardware is then also connected to via the network to a computer which is processing it, and there we are also offering two different devices. One is a boxed PC solution which is very flexible in use, where you can put it, and if you have a 19-inch rack on your computer, we of course also offer you a 19-inch version of that computer. Coming to the approach, the data capturing approach from our product. So what is the big benefit of such a 360-degree LiDAR is that we get all the different obstacles or assets along the track in one scan frame. So therefore, we don't have any other measurement uncertainties what we have to consider. So we just have the scan frame, and everything else we just don't have it. So as you can see also in that picture, we have on top, we have the catenary wire, we have here the scanner position, and we have also the track. Which leads then to a measurement of the stagger of the catenary wire here in that example, and of course also of the height. The height is then related always to the top of the rail, and the stagger always to the track axis. So the scanner detects the track, it produces the track coordinate system based on that detection of the track, and related to the track coordinate system, it's measuring the stagger position, so the catenary wire position. Now coming in details to the different functionalities or features of our tmENV system. We start things off with the catenary wire measurement. As already said before, we have the height measurement, the stagger measurement, and what we have additionally is a mast assumption based on the stagger, so based on the zigzag of the catenary, we are detecting the position of the masts, and we are also calculating then the distance between the masts. What is very special, and what I have said already before with the catenary wire crafters, we have that stationary mode, which enables just a presentation of the current measurement of the catenary wire for working with catenary wire crafters. So without recording anything, but presenting the actual position for the workers, that they don't always have to leave the basket where they are changing the position of the catenary wire. They just can stay there, they see the actual position, and they can work more effective than before. The standard mode, of course, is like for all other measurements, the dynamic standard measurement. Coming to the representation of the data, you can see we have there our system protocols. Maybe a little bit an intro to the system protocols. All our products are producing system protocols in our platform solution tmOS, and that system protocols have several areas or levels where you can see data, and that I want to present to you today. So what you can see here as an example is the assigned catenary wire, which is more or less the thresholds which are assigned to the track sections. So you can assign every 25 centimeter a different catenary if you like, and then have changing thresholds for every 25 centimeters, which will not be the case. But if you have a tunnel or a station area, maybe the thresholds are lower and you can adapt this, and it will also be adapted while live measurement. Yeah, then you see the stagger, you see the height, and here also the mast assumption based on the zigzag. Additionally to that system protocol, we also have customized CSV exports and PDF reports for the cat wire measurement, where you can see also then the data which is available in the protocol. The next product what I want to show you today is the ballast profile measurement. So based on a defined target ballast profile, we are measuring the lag, or we are calculating the lag and the surplus of ballast for the left and the right side of the track. The ballast profiles are fully configurable in our internal built-in editor for the ballast profiles. You can also add correction values, as an example, from a pre-measurement from a tamping machine, to also consider that lifting and shifting values for the calculation of the ballast, that you don't put too less ballast into the track before you work with your tamping machine. Then, of course, also the ballast density can be changed, that you have the right density. And of course, also sleeper types and rail types can be defined. What we get then is, again, of course, a system protocol where you see the assigned ballast profiles. You can see here that we have at the beginning a different ballast profile than later, then the tie type, the rail types, and here also the applied lifting and shifting values. So as you can see, the track was lifted around 2 centimeters here, 20 millimeters, here a little bit more, and shifted to the left side. And this is then also, respected in the calculation of the mass or the volume for the protocol. When you click then on a 25 centimeter bar, where you can see exactly the amount of ballast which is needed, you can also have then that cross-section view of the ballast here. And if you want to know the whole amount regarding volume or mass, most probably you will need the mass more. You can see that in the side sheet. And if you want to know a subset, you just can use that button here in the system protocol to hover over it and then show you the mass from that subset of data. The third feature what I want to present today is then the clearance profile measurement. The clearance profile measurement is detecting several obstacles like low-hanging branches, loose catenary clamps, or also signs in the area of risk if they are violating the defined clearance profile or also the extended clearance profile, which can be seen here with that dashed line. What we do additionally to that measurement, we can also dynamically adapt the clearance profile based on several factors like the measured curvature, detected platforms, or also the catenary wire height. The system protocol for that product then looks the following. So you see how many violations you have on that position and how many warnings. I have used today for the presentation an area where we have a constant violation here over several hundred meters, because that's what I have found, very short, and is also very placative for the presentation. This violation here, you can see on the next slide, is a platform. So that platform here is the violation which we are showing. You also see here the position, which is within that range, which means we have 194 meters in total for that violation. It starts here and it ends there, and it is a platform. So very easy to detect then what it is with the scanner frame. What you can open up here, you see here also that violation. It's the same one as also shown in the list view. So you have a total view of all violations, and you have the single view for every scan frame where you see what violations and warnings are there. Coming to the next feature, it's the track distance measurement. The track distance measurement is measuring the vertical distance between the top of the rail of the adjacent tracks left and right, as you can see here with the A. And the horizontal distance can be measured between the wheel flange points or the track axis. This can be defined by the by the machine operator and will be one time configured while commissioning for the machine. And for that measurement, of course, also the super elevation is considered, as said already at the beginning, because also the machine, when it's running along the track, is leaning into the curve according to the super elevation. So therefore, we also have to consider that in that measurement. For the system protocol, we have here again a track distance, which are defining the thresholds what we have, which is more or less the minimum horizontal distance between tracks. And then we have the left track on the top. Then we have a combined view for left and right in the middle. And for the right track, we have here again a dedicated chart. What you can see here is typically a switch area, and it's violating the threshold, but it's not red. The reason behind that is that we are detecting if it's a switch area or not, and if it's a switch area, so it's a merging or a diverging of a track, we always consider it not as a violation, we consider it as a merging or diverging, and therefore it's marked in blue and not in red. If we would have a violation, of course, it would have been red. The last feature from our standard algorithms I want to show you is the platform edge detection. Platform edge, clear, we are measuring the horizontal distance to the platform from the wheel flange point and also the vertical distance to the platform from the top of rail. How does this look like? So we are detecting, of course, the platforms. We are presenting then in the system protocol the length of the platform also, like here we have a left platform and a right platform. And we also measuring, of course, the distances there and showing the thresholds for the horizontal and for the vertical distance for the platform. You see then also here in a table view the start and the end again for the platform, left and right. And you can also see here then the minimum horizontal and the maximum horizontal distance and minimum vertical and maximum vertical distance. This is very handy because if you can have a look on that at once, you immediately know what are my extreme values and if I have to do something. Of course, you see it also if you have a violation in the system protocol, but in that table view, you have really the concrete numbers here. And thinking back now about the violation, what we had from the left platform and also the platform what we have detected, we see now here that we have that violation, what I have told you before regarding the left platform. We have here a left platform detected, and we also have here the whole measurement values. So with that combined job view, which is enabled in tmOS, if you use our platform, you really can get a big insight into all the data what we have. So you see, okay, I have the platform there, so that violation should be that. Then I can open up the scan frame, can see in detail if it is really the platform. And of course, we have here some more violations sometimes, but in general, it's always that one violation which is constant is the platform, which is, of course, here also ending exactly with the same position as the platform. What is also fully integrated in tmOS are our editors. So as I show you here, the editor of the clearance profile, we have such an editor also for the ballast profile. So you can define your profiles as many as you like. You can assign them to the track every 25 centimeters different if you like. And yeah, it gives you the full possibility to edit here your needs to have really the right measurement done for your tracks. Last but not least, from our functionality perspective, I want to tell you also that we have the possibility to export also the raw data. So we have the LAS and LAZ export, the PLY exports. We have also the what is additionally, if you just have the scanner and you have the export of the raw data, you don't have any reference to the track. So what we don't have only the raw data, we are referencing all the points to the track coordinate system and presenting then the data to you that you can use it also for further analysis in your own developed solutions if needed. And of course, also the echo information is provided with each data point. To close things up a little bit today, I want to tell you also, or show you some figures regarding the precision. So as you can see, we're sometimes even below the precision values from the scanners. That's due to the fact that the precision values from the scanner are measured at 30 meters. What we are presenting here are values, of course, which are measured much closer, and of course also considering here our algorithms and other influences what we have regarding the repeatability and reproducibility. How we have performed the measurements, it's according to track geometry measurement systems. We have done it in a state in the same way as you perform it for track measurement systems. And if you want to have more details about the performed tests, just came back to us afterwards, after today, then we can also give you some more insights into the tests performed that you can understand the results better. Also, important information from our side is the maximum measurement speed. So due to the fact that we are presenting the data every 25 centimeters, we would suggest you to measure with a maximum speed of 200 kilometers per hour with the Regal books and with 80 kilometers per hour with the SICK. Because yeah, if you're going faster, you will not have a measurement every 25 centimeters, so a full rotation. And that's what we don't want to have, to really have good data available for our measurement. So last words from my side, tmENV, let it scan also for you. So if you have a new machine, an old machine, we are really happy to help you. I think for most of infrastructure companies, there are really use cases where they can use that product and where it is really beneficial for them. So came to us and contact us. Thanks for your attention for today. And if you have any questions, we are still here for several minutes. We are happy to answer them for you. Maybe regarding the questions, just write them in the chat, please. So then we can take them and answer them. Yeah, we got already the first question. Yes, it is possible to also mount it on existing vehicles. We just have to look what is already there on the system regarding network connections, regarding the mounting positions, and we have partners where we with them together then enable it really to have there a good solution on your machine. Also regarding your measurement equipment on your vehicle, what we can reuse from that, because yeah, all what is already there could be reused and must not be installed new or purchased new. So we are here flexible, but yeah, we would be happy to help you if you contact us afterwards. If there are, okay. So regarding geo-referencing of the data, we can do it if we combine it with an RTG measurement system, if this is available. Otherwise, of course, this is just an internal measurement. You can add, of course, GPS coordinates, which can be used. And then, of course, it's depending on what if you're using an RTK service, the GNSS coordinates are more accurate. If not, of course, we have the standard deviations from 2 to 5 meters for a GNSS signal. And yeah. But if we have the RTG measurement system, then we are also able really to have here high precision values in sub-centimeter yeah, areas. So regarding georeferencing. Yeah, we have another question. If there are any influences of heavy rain, snow, and fog on the laser? Yeah, let's see. Of course, it's an optical measurement system, so you have influences of heavy rain, fog, etc. But what we can see is if you compare it with another optical, like a camera system or something like that, LiDAR gives you a much more feedback than, as an example, a camera. But of course, if the snow conditions or the fog conditions are too heavy, we also have the same problems as every other system which is based on photos or visual system. Are there any other questions? If you don't want to ask the question now in this round, it's also okay. Just send us also then per email the questions, etc. We would be happy to answer that. Just give us a call, contact us. We are also happy to organize meetings with you directly to discuss your personal needs. So then I would say thanks for your attention today. I'm happy that you all joined today. I hope you got some good insights on it, and we wish you all a good start in the year, also from TMC in 2026. Have a nice rest of the week, and we hear each other on the next webinar. Thanks for your attention.